All right, this was the big result from last time. In any infinite context-free language, we can find a string, UVWXY, in the language. I should have said in the language, with v and x not both epsilon, such that u v to the I, w x to the I, y is in the language for all I greater than 0. All right, you can use this bizarre fact to show that things are not a context-free language. Let's just do some examples. All right, everybody's favorite example, and when someone, if a stranger approaches you and asks you for an example of a language that's not context-free, this is what you should say. A to the n, b to the n, c to the n. This is not context-free. All right. Now, just like when we showed that things are not regular languages, really you have to write a little sort of baby proof for this every time. And, lucky for us all, most of the proofs will look very similar from one problem to the next. So it has a very specific format, and hopefully if everything works out, you can just kind of swap a few of the details here and there, and everything will be fine. So this A to the n, B to the n, C to the n is not a context-free language. How do we demonstrate that? All right, it's always done by contradiction. So you assume, for the sake of a contradiction, assume that, can I call this L? L is context-free language. Then, according to the stuff that was written at the beginning of this video, that means then there exists some string u, v, w, x, y in L with v and x not both the empty string, such that u, v to the I, w, x to the I, y is also in L. Now, in this example, and actually in most examples we talk about, you don't even need, and I should say for all, it's in L for any I greater than 0. Now, in this example, and actually in pretty much any example that we're going to do in class, you don't even need this for any I. You can just say this for I equals 2, and it'll be good enough to derive your contradiction. So in particular, u v squared w x squared y is also in L. All right. Now, these words which I've written so far, I have made no mention of the particulars of this language yet. So actually, in every example you're ever going to do, you can start off by writing these words exactly as written here. Even using the 2. There's some weird examples where the 2 is not good enough. You actually have to use every I here, but in our case, usually the 2 is good enough. All right, all of your proofs basically will begin with these words. Now we have to explain what the contradiction is, and the contradiction has to do specifically with the format of the strings here. So if we assume the original thing is in L, u, v, w, x, y is in L, so that means this thing, u, v, w, x, y, looks like A, well, it has to look like A to the K, B to the K, C to the K, right? Okay, so I guess like what that means is the U, you should feel like the U is mostly A's, and then the Y is mostly C's, and then at some point in the middle, these things, some of them are B's, something like that. Like just these, we have KA's, KB's, KC's. Those have to fit somehow into these substrings, right? You break this into 5 parts, and each part is like that. Some of the parts could be empty, but the only rule is that V and X cannot both be empty. Okay, and here's the important part. And U V squared W X squared Y is also, this also looks like A to some power. It's not going to be the same power, right? But it's A to something, B to something, C to something, right? And I ask you, my friends, is this really possible? Is it really possible that this string could look like that, and also this string could look like that? How could this actually be? Well, I would say it is possible. It is possible, for example, if the V was all A's, then after you do v squared, the first part will still be all a's, right? I would say this definitely is impossible if the v has some mixture of a's and b's in it. If the v has, say, an a followed by two b's, then when you do v squared, you get ABB, ABB, which is definitely not of this form. All right, so if this is going to be true, then I'm going to say v and x cannot use a mixture of letters. By that I mean they are either just all A's or all B's or all C's. If they have any mixture of letters, some A's and some B's, then when you square them, the order will get all messed up. It won't be all the A's first and then all the B's. They'll be messed up, right? And similarly for the X cannot have some mixture of B's and C's. It has to be all C's or all B's, or else the format of the string will get screwed up. All right, so V and X cannot use a mixture of letters. That is to say, they're either all A's or all B's or all C's. Of course, they don't have to be the same. It could be that V is all A's and X is all C's, whatever. All right. What does that mean, though? This is going to give us a contradiction. V and X cannot use a mixture of letters. So, what happens then? Think about how the pumping would go. So, when we change from this string, u, v, w, x, y, which is in L, to this string, u, v squared, w, x squared, y, what happens in the string? Well, what happens is, whatever letter v is using, v is just using a single letter, maybe it's all A's or all B's or all C's, that letter, we are increasing the number of those, all right? So when we change from this to this, we increase the count of the letter used in V and also in X, right? Whatever letter, like V has to be made up of a single letter, whatever that is, that we have more of them now than we used to, right? And same for the X. Whatever the letter the X is using, we now have more of them than we used to. But that's it, right? The only thing that changed was the number of things which are of the letter that V is using, and also the number of things which are of the letter that X is using. We did not change the number of all three letters, which is what has to happen in order to maintain this form, right? What this means, since we only changed the number of 2 out of 3 of the letters, this form cannot be preserved. So if this is of the form A to the k, B to the k, C to the k, this cannot also be of that format because we changed the number of 2 of those letters, but not the third, all right? So, what this means is that I will say thus, u v squared w x squared y is not in L since we increased the number of 2 letters, but not the third. All right. And this is a contradiction. So this contradicts the fact, because we said at the outset, u v squared w x squared y is in L, right? We already said that, but we just demonstrated it cannot be. If you jack up the amount of 2 of the letters but not the others, then this thing cannot be of that same format anymore. All right, this is why the language A to the N, B to the N, C to the N is not context free. It's a long road that it took to get there, but that's why it's true. All right. I just want to do 2 more examples. Like I said, they will be written very similarly. You're gonna, sort of have this basic proof in your mind and see if you can just copy the details. Maybe you can write exactly the same thing and it all will still work. Let's try it. All right, let's try this one. Let's show that a to the n, b to the n plus 3, c to the n is not a context-free language. It's really not, and the proof of this is almost exactly the same. Maybe every single word is exactly the same. Not exactly, but very similar to the one that we did before. I'm going to say, for the sake of a contradiction, assume, let's call this L. L is a context-free language. Then there exists U, V, W, X, Y in L. Such that U, V squared, W, X squared, Y is also in L. Like I said before, really this is true for any exponent there, but in all the examples that we're going to do, pretty much the exponent of 2 suffices. All right. You want to say the same, try and say the same kind of thing about mixing of letters. So U, V, W, X, Y looks like A to the K, B to the K plus 3, C to the K, right? And that means if U, V squared, W, X squared, Y has the same form, it is also true in this example for exactly the same reason as before. V and X must not mix letters, right? Because if V had some mixture of A's and B's, then when you square it, it's not going to look like that anymore because the ordering will be messed up. You'll have some A's after B's. And similarly, if X had some mixture of A's and B's or B's and C's, that screws up the format. So V and X must not mix letters. I mean, V is all just one letter, and X is all just one letter. They might be the same letter, they might be different. Okay, but then, for the same reasons as we see in the previous example, when you switch from this to this, you have increased the number of only 2 of the letters and not all 3 of them, which means this format cannot still hold, right? Because in order to maintain this format, you need to be adjusting all 3 of them. So I'm just going to say the same stuff I said last time. Changing from U, V, W, X, Y to U, V squared, W, X squared, Y. We increase only 2 letters. We increase the number of only 2 of those letters, right? Whichever one is being used by V and whichever one is being used by X, but not all 3. So it's not possible actually that U, V squared, W, X squared, Y is in L. So this is not in L, and that's the contradiction. All right, it's not in L because in order to be in L, you have to maintain this balancing between all 3 of the letters, where the B has to be 3 more than the A's and the C's, right? And if you only change 2 but not all 3 of them, that's not going to work. So this string right there is not in the language. All right, I got one more. I would like you to try it, and then I'll come back and see how we do it. How about this one? A to the n, C, B to the n, A squared, C to the n. N and n, of course, that's always what I mean. All right, this is not context-free language. Can you do it? See if you can write a proof. Maybe it looks the same. They're always going to look some variation of what I wrote before. See what you think. All right, did you write the same thing? If you did this correctly, you might feel like I'm just saying the same thing over and over again. Yes, you are. It is the same argument you use for all of these different examples. Any example really that has this kind of triple balancing can be demonstrated using the same argument. Now, there are many other weirder examples where this same argument doesn't work, but I don't want to get into that. They are weirder. This is suffices for what I want to do for examples. But anyway, let's see what you said. So, as usual, I'm going to say, for the sake of contradiction, assume that L is a context-free language, and then this means that we have some string U, V, W, X, Y in L. such that v and x are not both epsilon, and u v squared w x squared y is also in L. All right. Can we say the same thing about the mixing of letters? This is a weirder form. Is it possible that this actually does allow some mixing of letters in the V? Well, I don't think it's possible. This V here, if this V, for instance, had like the V you should think of as being a substring towards the beginning somewhere. If it was, say, a C and one of these B's, then that's not going to work. If you square that part of it, you get CB, CB, which doesn't fit this format anymore. However you slice it, it is still true that the V and the X are not allowed to repeat or are not allowed to mix up any letters, because if they did in any way, if you mix the letters together in some way, it would screw up the format of this string here. So again, I'm going to say V, not U. You can mix the letters. V and W can't mix letters. So I can just say the same stuff that I always say. So when we change from UVWXY to UV squared WX squared Y, we change the number of two letters, but not all of them. And so this means if you take a string that has this format and you change the number of, say, A's and B's, but not the number of C's, it cannot possibly have this same format again. All right? It requires these A's to match these B's to match these C's. They have to have the same amount. So if we change the number of two letters, but not all three, so that means that this UV squared WX squared Y is not in L, and that's the contradiction. All right? That's it. One thing you should be concerned about is you keep saying the same argument over and over again. You should feel like, wouldn't this work like for anything? Maybe like no language is context free. Can you just say the same words for any language? No, you cannot say the same words for any language. This argument will not work in many cases. For instance, if you're talking about this language, A to the N, B to the N, which we know is context free, the same argument will not work for this, because this business about we change two of the letters but not all three. Well, here there are only two letters, and so it is possible to get from here to another version of the same format by changing only two letters. The reason it doesn't work in this case is because there's three different letters that all have to match each other, and if you only change two but not the third, they can't still match each other. All right, this is how you show that certain languages are not context free. That'll do it.